lesson, we're going to learn about something you'll hear a lot of moving forward through pre-algebra and into algebra, the slope of a line. Now, the textbook definition of slope is that it's the ratio of the line's vertical change to its horizontal change. So basically it refers to the incline of the line, whether the line is horizontal, vertical, climbs, or descends. In algebraic terms, the term slope is referred to by the variable m. So when we see ratio, we know right away there is a fraction involved. Now, we talk about the vertical change. That is the rise of the line, the vertical change of a line, which has to do with its climb or its fall. And then its run, which is the horizontal change of a line. And it's important for you to know that lines are read the same way that we read text, from left to right. Now, when we talk about the slope of a line, there are four different possibilities that we will have. If the line has a positive slope, it means that the line will move from left to right in an uphill fashion, starting lower and then climbing higher. If the line has a negative slope, then again, reading from left to right, the line will fall. It will go downhill, so to speak. If there is no slope, that means that there is no climb. Then the line will be just a perfectly horizontal line running through the y-axis at some points. And if we have a line that has an undefined slope, then that means it is a vertical line. And if you remember from lessons past, vertical lines means that it is not a function. And again, lines are read from left to right. So let's take a look at some examples. In this lesson, we have 5. In example 1, a skateboarding ramp has a rise of 6 feet and a run of 15 feet. What is its slope? Now, as I said before, the fact that slope is ratio, it means that there is a fraction. And so this is how we have to look at slope. Rise over run, because remember, slope is a ratio of the vertical change to the horizontal change. So the way that the line rises, moves up or down, divided by or over its run, its vertical movement. So for this example, if the rise is 6 feet, then our slope equals a 6 in the numerator, and the run is 15 feet, its slope is 6 over 15. And just like with all other fractions, we simplify. 6 over 15 is the same as 2/5. So the slope of this line is 2 over 5. Now, it might seem a little strange, but as we work through this lesson and the next, you will start to get a better understanding of what this means in real terms. Now, example 2 is a little different from example 1. It's a little bit more involved. Given 2 points in a non-vertical line, find the slope. So here we have a line with 2 points on it, point 0, 1, and point 3, -3. And you're going to see problems like this pretty often. There is a formula to follow. M, which you remember means slope, is, and this is just putting what you've learned already so far in this lesson into different terms. The difference of the y coordinates, because remember the y-axis is the vertical axis, so it's our rise divided by over the difference of the x-coordinates. Our x is our vertical axis, and remember, slope is the ratio of the horizontal change of the line to the vertical. The vertical to the horizontal, pardon me. So our formula, whenever we're given 2 points and you have to find the slope, and you will even use this moving forward into Algebra 1, is the difference of the y's, which we call y sub 2 minus y sub 1, over x sub 2 minus x sub 1. So what does that mean? It means we're going to call 0, 1, our x sub 1 and our y sub 1. And we're going to call our second set of coordinates x2, y2. So we start with the formula again. y2 minus y1 over x2 minus x1. So now it's just a substitution game. We substitute what we've already labeled. So we have our y2, which is a negative 3, minus our y1, which is 1, over 3 minus 0, which is our x sub 2 minus our x sub 1. And then we simplify and we end up with a negative 4 over 3. Now it's important to know that not all fraction rules apply to slope. We do simplify to its simplest terms. However, we keep improper fractions as improper fractions because we need to know what the rise is and what the run is. And we can't do that if we have a mixed number. Now I know this sounds a little complicated, but what we're going to do in example 3 is take 2 points and use this formula to find the slope. So find the slope of the line that has these 2 points. And I already started us off. Here are our 2 points, negative 2, 4, and positive 6, positive 8. And I went ahead and I've already labeled them x1, y1, x2, y2. And just as I've always said, no matter what we're doing, start with your formula. Slope equals the difference of our y's, y2 minus y1, over x2 minus x1. Now that I have my formula and my labeled coordinates, all I have to do is plug in the numbers. Our y2 is 8, and we have to subtract from that our y1, which is 4. Our numerator is done. Now let's do our denominator. x2 minus x1, so it's 6, minus, and what's our x1? A negative 2. It's important to remember and to realize that this minus sign is applied to the x. It doesn't take the place of a negative in the x. That's why if you notice I wrote my x in parentheses, because I want to remind myself that I'm subtracting a negative 2. And now we simplify. 8 minus 4 is 4. 6 minus a negative 2 is like adding. So 6 plus 2 is 8. 4 over 8. And of course we simplify. So for this line, the slope is 1 over 2. Now for example 4, we're going to work just on the graph paper. Sometimes you'll be presented with a problem like this, where you're given a line, and you're asked, what is the slope of this line? And you might think, how do I even know where to begin? Well, the first thing I want to point out to you is that when we're reading the line from left to right, you see the line goes down. This line has a negative slope. So what have we been doing so far to find the slope? We have been given 2 different points, and then from there we use the slope formula, the difference of the y's over the difference of the x, so the difference of the rise over the difference of the run, and from there we work out our ratio and we get our fraction, our slope. Here we're given a line, we can do exactly the same thing. All we have to do is identify two points that are on this line. Here we have point 1, 3. And here we have point 2, negative 2. Now that we have our 2 points, we can very easily determine what the line's slope is. The first thing I'm going to do is label this ordered pair as x sub 1 and y sub 1. And then I'm going to label these as x sub 2, y sub 2. And if you remember, our slope formula is y2 minus y1 over x2 minus x1. And so what this means is negative 2 minus 3 over 2 minus 1. And when we simplify, we get a negative 5 over 1. And as I said before, even though this is an improper fraction, we keep it as such because we need to easily identify our rise and our run. And you're just going to have to trust me on this. As we move forward working with slope, this will have much more value to you. And before we're done, we have one more example. And what example 5 does is it combines for you what we learned in the previous lesson when we first introduced slope, and here what we've learned today with finding slope. Our problem reads, find the coordinates of 2 points on the line with the given equation y equals 4x plus 3. And then find the slope of the line. This sounds pretty complicated. Y equals 4x plus 3. What I'm going to do, just to make it a little bit easier, is to change this to y equals 4x plus 12. And you'll understand why I did that in just a minute. Find the slope of the line. Well, this is even more confusing than problem 4, where we had the graph and we had to pick out the lot and the points. But trust me, you can do this. Find the coordinates of 2 points on this line. In the last lesson, you learned about the x-intercept and the y-intercept. And that's what we're going to do. We're going to find the intercepts of this line. That'll give us our 2 points. And then once we have our 2 points, we can find the slope. So if you remember, to find the x-intercept, what that means is we are looking for point x0. And then to find the y-intercept, it means we are looking for point 0y. I've written my coordinates. If you remember, that's our first step. Our second step is to rewrite the equation. Here we have y equals 4x plus 12. And I'm just going to go ahead and do it on both sides. Y equals 4x plus 12. Our third step in finding the x-intercept is to substitute the y with a 0. So we have 0 equals 4x plus 12. Now this equation, because of the way that it's set up, and we don't have the x and the y on the same side of the equal sign, this will have an extra step. But this is a skill you learned way back near the beginning of the year, where we were just solving equations to find the value of the variable. Our goal here is to get the x by itself. And right now, the x is being kept company, so to speak, by 2 numbers. It's coefficient 4 and the constant 12. And if you remember from what I taught you way back months ago, the first thing to do is to get rid of the constant. And what we're going to do is subtract 12 from both sides. So we have 0 minus 12 equals 4x plus 12 minus 12. 0 minus 12 gives us a negative 12. This positive 12 and this negative 12 together make a 0, and that leaves us with 4x. Our next step is to divide both sides by the coefficient 4, so we can have the x with a coefficient of 1. And the value here, x, is negative 12 divided by 4 is a negative 3. So our x-intercept is negative 3, 0. And now we're going to do the y. This time, instead of substituting a 0 for the y, we're going to substitute a 0 for the x. So our y stays the same, 4 times 0 plus 12, and this is a lot easier. Y equals 0 plus 12, so y equals 12. And that means that our y-intercept is 0, 12. Negative 3, 0, and 0, 12 are 2 points that are on the line represented by the equation y equals 4x plus 12. Now that we have our points, finding the slope will be a snap. What I'm going to do is up here write down what our 2 points are so that we remember. Negative 3, 0, and 0, 12. The next thing I'm going to do is to label these. I'm calling negative 3 x sub 1, and I'm calling it's 0. This y sub 1, which means this is x sub 2, and that's y sub 2. My next step is to, of course, write the formula. M equals y sub 2 minus y1 over x sub 2 minus x sub 1. And now we substitute. Our y2 is 12. Our y1 is 0. Our x2 is 0. And we're subtracting from that our x1, which is a negative 3. Now we simplify. 12 over positive 3, positive 12 over positive 3. Remember what I said before? We simplify, but we keep our fraction improper, which means this will simplify to 4 over 1. So the equation that has these 2 points on it, y equals 4x plus 12, has a slope of 4 over 1. Well, that's it for today. It's not as long as last time, and moving forward, we will take everything we've learned in the past 2 lessons and apply it to something more interesting.